I'm going to show you how to solve this differential equation by separating the variables. Notice that there are extra information given here which tells me that I'm supposed to find particular solution. So before I can separate the variables, I will have to move cosine y to the right first. So now I'm going to move all the y terms, which is here, here and here, to the left hand side. So sine y remains. Negative cosine y can move over. And dy remains. And I'm going to move all the x terms to the right hand side. So 1 plus e minus x goes to the denominator. And dx goes across. So now I just have to integrate both sides. To integrate the left hand side, I'm going to use a substitution. I'm going to let u be the denominator. So du dy gives me negative sine y, which I can see here in the numerator. So du will simply be minus sine y dy. So minus sine y dy will simply become du. So let me make the substitution. Minus sine y dy becomes du, and cosine y becomes u, so I just have 1 over u. To integrate the right hand side, I'm also going to use integration by substitution. To avoid the confusion, I'm not going to say u, I'm going to say w. Let w be e negative x. So dw dx is negative e negative x. So dw is negative e negative x dx. And in this case, I can see e negative x is w. So let me divide this part over. Since e negative x is w, when I divide over, I'm just going to write w. So I have dw over w equal, there's a negative, I'm going to bring over 2, and I'm just left with dx. Now I'm going to do the substitution. I have 1 over 1 plus e negative x. So 1 over 1 plus e minus x, e negative x, which is w. Then I have dx. dx can be written as negative dw over w. Now the left hand side is simple enough. I'm just going to leave it and integrate later. Now the right hand side, some things has to be done. So firstly, negative will come out. And this denominator can go together. So to integrate this, I'm going to do partial fractions on this term. So I'm going to leave it to you, but I just start for you. So you can do partial fractions on this term by letting it be a over w plus b over w plus 1. So you can find your a and your b. So you can do this on your own. But let me assume that I've already found it. I found that a is 1 and b is negative 1. So I think I'm ready to perform integration. Integrate 1 over u is ln u. Integrate 1 over w is ln w. So I have negative ln w. Integrate 1 over w plus 1 is again ln. I have a negative and negative, which makes a positive. And a plus c. Now let me sub the u back. U is cosine y. Let me sub the w back. W is e negative x. I see that there is 2 ln here. In fact, it's this ln term minus this ln term. Then there's an interesting ln result. Let me show you. I know that ln a minus ln b gives ln A over B. So I have ln A minus ln B should give me ln A over B. So simplifying this, I can split this fraction up. I have e negative x will cancel e negative x, and that will give me a 1. I have 1 over e negative x. 1 over e negative x can be rewritten as just ex plus c. So now I'm going to find the value of c that will satisfy this extra information. We know that when x equals to 0, y equals to pi by 4. So let's sub inside this expression. Ln cosine y where y is pi by 4 is equals to ln 1 plus e exponential of x where x is 0. So exponential of 0 is another 1. So ln cos pi by 4 is 1 over root 2. And I have ln 2, which gives me c. So once again, I'm going to use this trick. If you see the subtraction of logarithm, I can change to division. So I'm going to take this here, the logarithm of subtraction. I can take this divide by this. So ln 1 over root 2 divided by 2 is 1 over 2 root 2, gives me c. Now I can sub back into this expression here. Plus c, which is this. So another interesting result about ln is that when you have ln A plus ln B, it becomes the ln of product. So I see ln A plus ln B, I can change this product. So since there's ln on the left and ln on the right, I can cancel them because I can take exponential on both sides and the ln will disappear. So my final answer is this. This is my final answer. This is my particular solution.